Good evening, everyone. I'm Shreya Verma, a PhD research scholar, a PMRF student in the Department of Civil Engineering, IIT Roorkee. And I'll be taking your tutorial class for the week 8. And in this class, we'll be having previous year assignment questions for the week 8. That includes your lecture for, I guess there's some case study which was conducted in nursery buildings in UAE. Apart from that, we'll also be having questions from the topics of global and regional environmental issues, for example, acid rain, climate change, then your global warming and all that. So let's get on to the questions that we have for the week 8. So coming towards the first question, we have in the case study presented for the nursery buildings in UAE, which of the following methods was not carried out for the improvement in indoor air quality? See, certainly in the last class, we have discussed some of the methods that can be taken to improve the indoor air quality. Those included to improvise the ventilation strategies or to clean up or the maintenance of your HVAC systems. Then also we have certain purifier systems that can be used for that. Okay. Good evening, Harsha. Okay, since you've joined just now, I've started the class, but we can start over again. So I was in the first question only. So the first question is that see, today we have a discussion for week 8 questions, and in that we'll be covering the topic for that case study that was on the nursery buildings in UAE. And apart from that, we'll have our local, global, and regional environmental issues, which include your climate change, your acid rain, your global warming, and all that. And so I was on the first question only. The first question is that in the case study presented for nursery buildings in UAE, which of the following methods was not carried out for the improvement in indoor air quality? Options are installation of air purifier, change of building material, installation of new ventilation, and using ESP and ionizers.
Using ESP and ionizers.
Okay, true. So let's have a brief look into the improvement methods that were taken for each nurseries and what are their like uh, advantages or what are the benefits of using them and why to use a certain type of improvement strategy and not the other. Let's have a quick look into that. So three types of improvements were carried out in this study. First one was to install an air purifier that would remove the indoor air pollutants. Next was in some classes they have changed or change the building materials or the furnishing materials, so that could have removed the source of pollutants. For example, changing some of changing the earlier materials with the less polluting materials that would emit lesser amount of formaldehyde or the VOCs. Next up, we have your installation of new ventilation equipments so that there is some dilution in the polluted air and thus the concentration of the pollutants can be reduced. So these are the three methods that were used to improve the air quality in this study. The improvement work was determined in consideration of the indoor air quality measurement results. Basically, firstly, they have carried out the test for the indoor air quality, and according to the quality of air that they got in different classrooms of the nurseries, they have chosen the type of improvement plan which is suitable for that nursery. So this is some detail of that number of rooms which have installed the air purifiers. I guess 10 out of 16 rooms have the air purifier installs, and rest in the rest 6 rooms, three have the changed in building materials, and three have the installation of new ventilation strategies. So the first one is that the installation of air purifiers. So it is the most preferred plan because it is very easy to install. See, in our homes also, if we want to improvise the air quality, the first thing that we consider is just to have an air purifier at our homes. But the problem is that it is like it is suitable for a smaller area, because it will be confined to a particular space in our houses. So the purifier is suitable for those classrooms because that were not of very much bigger sizes, or like there's not much movement included. For example, see, if we are considering multiple rooms, then that one single air purifier will not be suitable for that. But if we are considering just one single room, and we are concerned about the air quality of that particular room, then installing an air purifier is an easy option. And also because it that would not hinder the like functioning of the classes. That's why air purifier was an like preferred option. Also, the air purifiers that they were using, the that has a built-in deodorizing filters, and it also removed the odors and the indoor air pollutants. And also, like the efficiency was more than 99.9% that was given by that air purifier. Next is your change of finishing materials. So they certainly replace the earlier materials, finishing materials, by the more eco-friendly building materials, and thus that is why the emission of formaldehyde and VOCs is less than 0.015 milligrams per meter square per hour, and zero point 0.1 milligrams per meter square per hour. And in some classes, wallpapers were replaced on the four sides of the nursery room walls, and also the flooring materials were changed, because in some cases the wallpapers that may also emit some of the VOCs or the formaldehyde. So that's why they were changed. And in the third group, we have like new ventilation equipments were installed where the ventilation was a problem. So because they were having very high amount of CO2s, so the method that was chosen was to enhance the ventilation strategies. And one device was installed in each nursery room so that the natural and mechanical ventilation were performed simultaneously. Now, I guess I haven't marked this question answer. Now, coming towards the next question. In the case study described as above, like the nursery buildings in UAE, and which of the following pollutants had the highest reduction rate with the ventilation facilities? So, in the three classrooms which were having a new ventilation facility installed, among all these four pollutants, the highest reduction was observed in the case of we have the four options as VOCs, then we have suspended particles, then we have formaldehyde, and then we have CO2s. So, among all these four, the highest reduction with respect to your new ventilation facility. Okay, I'll tell you. The highest reduction in percentage was for your TVOCs, because installation of new ventilation systems ensured that there is some dilution in the uh, air that was present in the classrooms, and due to that the VOCs that were at such high amount, in the classroom, they were reduced by a significant percentage of the average reduction rate of pollutant concentration with air was the highest in TVOC at 46.31%. The VOCs were approximately half as compared to before the improvement. Next up, we have suspended particulates that were reduced by 21.7%. Then CO2 was by 18.16%, and formaldehyde was by 13.7%. Okay, this is for the nurseries with the installation of air purifiers, and for building materials change. Oh, sorry, this was for the air purifier. Okay, sorry. Let's see. For the air purifier, the maximum reduction was in the amount of VOCs. The air purifier reduces 46.31% of the VOCs. Then it was followed by the suspended particulates. Then we have CO2 and then formaldehyde. Uh, Sorry for my confusion. Then the nurseries with building materials change. See, it is very significant that by changing the building materials, the major improvement will be in the concentrations, in the reduction of the formaldehyde and VOCs. So the decrease in the rate of formaldehyde concentration was 498.3%, which was about 5 times lower than before the improvement. And the TVOC concentration was 812.8, about 8 times lower than before. So this is with the building materials change. Now for the ventilation, in case of formaldehyde, the highest reduction rate was 79.7%. And then we have TVOCs, which were reduced by a rate of 52.94%. So this will be your formaldehyde. Now coming towards the next question. The compounds which contribute to ozone layer depletion by releasing chlorine or bromine when exposed to sunlight or are called as ozone discharging substances, ozone depleting substances, ozone depleting surfaces, and ozone discharging surfaces.
Also depleting surfaces, substances.
Yeah, the name in itself is self-explanatory because these are the substances that led to the ozone layer depletion. So these are termed as ozone depleting substances. Let's have a quick look at the ozone layer depletion. So basically, when the chlorine bromine atoms come into contact with the ozone in the stratosphere, which basically ozone is a thin layer of gas which is present in the stratosphere, and it protects us from the harmful UV rays that are emitted from the sun. So, when this ozone gas comes in contact with the chlorine and bromine atoms, they react with that, and that is why, then they further destroy these ozone molecules. So, one chlorine atom can destroy over 1 lakh ozone molecules. That is such a huge amount before it is removed from the stratosphere. So, no, that is why these CFCs that which are chlorofluorocarbons, and this is a type of gas that is basically in our homes. Our refrigerators use this CFCs, and these are chemically very stable compounds, and these remain in the troposphere for very long periods of time. So these CFCs are also used in our air conditioners that we use in our homes, ACs, our refrigerators. So, increasing the use of these CFCs has led to the depletion of the ozone layer because the chlorine atoms present in these CFCs react with the molecule of the ozone, and which were this one. This chlorine atom, this reacts with ozone, and that's why this ozone atom gets destructed. And It forms a compound of ClO3 and ClO, and oxygen molecule is released in this reaction. See this one, chlorine plus ozone, that forms a stable compound of ClO, and oxygen is released. So these CFCs in the stratosphere would imbalance the ozone formation, and how these CFCs release the chlorine atoms. Basically, these chlorofluorocarbons, that is a single compound. When it is exposed to your UV light in the stratosphere, it undergoes photodissociation. Due to the presence of that light, it undergoes into dissociation, and thus it produces chlorine atoms. And these chlorine atoms start interfering with the ozone in the stratosphere. But this reaction takes place. This chlorine reacts with the ozone molecule. It binds up with the oxygen atom and forms ClO, and oxygen gas is released in this process. So this is the basically the mechanism for the reaction of these chlorine or bromine. Reaction with bromine is of the same nature only. So that's these compounds are known as ozone depleting substances. Now for the next question. In which of the following regions the first incident of the ozone layer depletion was discovered? We have South America, Antarctica, Asia, and Europe.
Antarctica.
Yes, it was in Antarctica only. So the ozone layer uh, is as told earlier, it is a like thin layer of it is a thick layer of gases present, ozone gas present in the stratosphere. But at certain places, what has happened is due to these reactions with the uh, ozone depleting substances, the ozone layer has started thinning at some points. Due to this like depletion of the ozone layer, the layer gets thinner at certain places, and due to this the UV rays, they start penetrating through this layer, and that is very harmful. So that is why since these UV rays are reaching the Earth's surface, at certain places the temperatures are observed to be quite higher, because there the ozone is thinner as compared to the other regions. Now we have your ozone depletion timeline. So in 1928, the scientists synthesized the CFCs. So artificially they created CFCs, and then in 1973 they found out that it was present in the atmosphere. Then in 1974, two scientists, Paul J. Crutzen and Molina and Rowland, uh, discovered that these CFCs and also the nitrous oxides N2O, these can break down the stratospheric ozone. They realized that these are actually harmful compounds, and in the following year in 1975 they discovered that the bromine that was used in fire retarding halons and also agricultural fumigants, that is also a potent ozone depleting substance. Earlier, it was only chlorine that was being obtained from the CFCs, which was considered as a ozone depleting substance. In 1975, they realized that bromine also functions in the same way, and it also acts as a ozone depleting substance. Then in the year 1985, the British Antarctic Survey team that discovers the Antarctic ozone hole. Basically, it's not a hole; it's the area that is 7.3 million square miles. That at that particular area, the ozone layer is very thin as compared to the other areas. So that is the first evidence of your stratospheric ozone depletion. And this research reveals that the stratospheric ozone layer depletion, it has adverse environmental and human health effects because see, since the for example, consider this point, this ozone layer, it here it is present, that the layer is present, but in very lesser amount, it is very thin. So what happens is these rays, UV rays from the sun, these penetrate through this layer, and then in the Antarctica region, they have due to this ozone hole, the UV rays started coming onto the surface, and this led to the melting of the glaciers or the ice present in that region, and also the temperature started to rise as compared to the earlier times. Then in 1991, international scientists agree that CFCs are depleting the stratospheric ozone layer in the northern and the southern hemispheres, because these are the colder regions, the northern and the southern hemispheres. Basically, these are the colder regions, and the effect of ozone is quite visible because the glaciers are getting melted down, and the water level of the sea is rising due to this. Now, in the year 2000, the Japan Meteorological Agency that also reports the hole in the stratospheric ozone layer over the Antarctic is at its largest to date, more than twice the size of Antarctica. Basically, the hole that is over the Antarctica continent, it is more than twice the size of that continent. So you can imagine how disastrous is that. And then in 2015, WMO observed that the ozone hole is reported to be the biggest ever, exceeding that of 2006. Basically, this hole is getting bigger and bigger day by day due to the constant release of CFCs in the atmosphere. And these substances are constantly reacting with the ozone present in the ozone layer, and thus it is depleting day by day. Now, we have the next question. Dash is the amount of warming or cooling in temperature due to physical and chemical changes that affect the global energy balance and force changes in the Earth's climate. So, first is your global warming potential. Then we have annual greenhouse gas index. Then we have radiative forcing, and then the feedback process.
Global warming potential.
Let's see. Okay, so it will be your radiative forcing because it is the amount of warming or cooling in the temperature due to the physical or chemical changes that affects the global energy balance. Check it once more. I guess there's some confusion here. Yeah, it will be your radiative forcing only because your global warming potential is the ability of a greenhouse gas to trap an extra amount of heat in the atmosphere over the time, which is relative to 1 ton of CO2 emissions. So basically, the global warming potential was it was developed to allow the comparison of the global warming impacts of different gases, how impactful a certain gas, and the it was compared with respect to your CO2. So this will be your radiative forcing. So what is radiative forcing? Basically, we know that when energy from the sun reaches the earth, the see this energy when it comes down to the earth absorbs a certain amount of energy, and see this energy comes, some amount of it is absorbed and some is reflected back into the atmosphere in the form of heat. So, due to this, the surface temperature of the Earth depends on the balance between this incoming and the outgoing energy. If this incoming energy is way more than the outgoing energy, then the temperature of the Earth tends to increase. So, the average conditions tend to remain stable unless the Earth experiences a force that shifts this energy balance, that how much amount of energy is coming and how much is getting out from the surface. So, like, what is this radiative forcing caused by the various greenhouse gases? This is warming and this is cooling thing. I guess this picture is visible to you guys.
Yes, ma'am.
Okay. So, let's see the radiative forcing caused by the various greenhouse gases. So, we have some natural and some human activities. So, due to these human activities, some of the gases that are released, for example, your carbon dioxide, then we have methane, then we have halogenated gases, for example, chlorine oxides or bromine oxides, and we have nitrous oxide. So, these gases, like for example your carbon dioxide, this has a warming or a positive radiative forcing, and it tends to rise the temperature of the earth. And then we have methane and nitrous oxide. The maximum radiative forcing is caused by this carbon dioxide, and then it is followed by methane. Then we have halogenated gases. Also, some of the aerosol solids or the liquid particles, they have both type of radiative forcing. Some have cooling or the negative radiative forcing, and some have positive or the warming radiative forcing. So basically, a shift in the energy balance that causes the Earth's average temperature to become warmer or cooler. That is called radiative forcing, and it is calculated in terms of your watts per square meter. And if overall the temperature of the earth is rising or a warming effect is observed, then it is termed as your positive forcing. And on the contrary, if the overall temperature is decreasing and like a cooling effect is observed, then it is termed as negative forcing. So, like when these positive and negative forces are out of balance, the result is the change in the Earth's average temperature. Because see, at certain places we have negative, like these blue portions in this picture only. These in this picture only, these blue portions, na, these are having a cooling effect. Matlab, that means they have negative radiative forcing. And these yellow or the red areas, all of them have a positive radiative forcing. That means uh, they will have a rise in temperature. So when we see this overall picture, na, when we see this overall effect, it will certainly lead to a positive radiative forcing, which will lead to the increase in the temperature of the Earth. So some of these changes are natural, and some are due to anthropogenic or due to the human activities. And the changes in the greenhouse gas concentrations in the atmosphere, that also affects the radiative forcing, because that also tends to affect the temperature of the Earth in because the greenhouse gases, increased amount of greenhouse gases in the atmosphere tends to increase the temperature of the Earth. So that is one thing. Then this radiative forcing has been converted to the annual greenhouse gas index, AGGI. See, this is there. This for different gases like carbon dioxide, methane, nitrous oxide, CFCs, HCFCs, HFCs, HFCs. So the radiative forcing is certainly converted into this annual greenhouse gas index. It is basically a measure of the climate warming impact of the long-lived greenhouse gases in the atmosphere, and also how this impact has altered or has changed since the Industrial Revolution began, that is in 1979. So this annual greenhouse gas index, basically it was set to 1 for the year 1990, and after that like industrial after the Industrial Revolution in 1990, after that it's been increasing, the annual greenhouse gas index. And in the year 2019, I guess it was 1.45. So that represented a 45% increase in the radiative forcing, which was observed in 1990. It was increased by 45%. It became 1.45. That explains that the temperature of the Earth has risen since 1990. These greenhouse gases produced by the human activities, they also have caused an overall warming influence on the Earth's climate since the 1750. And the most significant contributor to warming has been CO2, and which is followed by methane. Basically, the CO2 is the major pollutant that tends to increase the surface of the Earth, and then it is followed by the methane and the black carbon. The production of the aerosols in the atmosphere, and the other activities uh, that have caused cooling uh, cooling effects, because the aerosols present in the atmosphere tend to serve as like they serve as a site which collects the on which the water vapor can condense, and these aerosols help in the formation of clouds also. So that is why they have a net cooling effect. Since the layer of cloud also helps us to like uh, the layer of clouds acts as a barrier that tends to hinder the rays coming towards the surface of the earth. Now we have the next question. The global warming potential of a greenhouse gas in comparison to CO2 after 100 years is known as GWP 100. So, what will be the GWP 100 of methane? Any idea how to find that?
Woman.
Okay, let's see. So, basically, what is global warming potential? Basically, it was developed to allow the comparison of the global warming impacts of different gases. So, the global warming potential of greenhouse gas, basically, it is its ability to trap an extra amount of heat, and which is relative to the 1 ton of CO2 emissions. And the more significant the global warming potential, the more that a given gas warms the earth compared to CO2 over that period. And the period that is taken for global warming potential is usually taken as 100 years. So, on what factors this global warming potential depends? Basically, it depends on two factors. First is how effective the gas is at trapping the heat. How much effectively the gas can trap the heat in itself while it is in the at present in the atmosphere. So basically, there's some tendency of some gases to trap the heat within themselves. So, how effectively they can trap that heat within themselves, that is one factor which affect the global warming potential. And next is that how long it stays in the atmosphere. Basically, how stable is that gas before it gets breakdown. So, these are the two factors that affect your global warming potential. For example, methane breaks down relatively quickly. So, like for on an average, the CH methane molecule stays in the atmosphere for around 12 years. And but it traps the heat more effectively than CO2. That is why we use methane in the biogas also, because it tends to trap the heat more effectively as compared to your carbon dioxide. And but CO2 is having a much longer lifetime. So, to having a standard scale for all the greenhouse gases, this allows us to compare between the emissions from the different activities or sectors, because every sector is having its own emission inventories. So, how do we compare that? How much emissions are they releasing, or how much emissions are being delivered in the atmosphere? So, to have a standard scale in terms of your global warming potential, it's easy to compare the emissions between different activities or the different sectors, and it also helps us to decide like how much effort we should be putting into the reducing the levels of different greenhouse gases. Like what should be our what should be our focus on, like which gas is to be is of prime concern, or on what activities we should be focusing, or on what sectors we should be focusing to reduce the amount of pollutants. And this global warming potential, it allows us the emission reducing strategies, and which target different gases while minimizing the economic impacts. Also, this helps us to formulate the reduction strategies, the strategies that we make to reduce the emissions. And also these target the different basically, by knowing our target pollutant and knowing which sector or activity that needs to be targeted, we can form the emission control strategies which are more economical and like more eco-friendly as well. Is the GWP 100 of methane? Okay, we'll come into that. Now, first, we'll be discussing the global warming potential of someone is there. Okay, first, we have GWP for methane in this graph, and then also we have it for your nitrous oxide, N2O. The total warming of a greenhouse gas compared to CO2 after 100 years. That is your GWP 100, and it is the most widely used scale. So the majority of studies or agreements also use this 100-year time horizon. And also the Kyoto Protocol and the Paris Agreement are also based on these GWPs from emissions over a 100-year time horizon. So the changes in the GWP values are made from time to time as we have improved our scientific knowledge and updates of the energy absorption. These values are getting changed with time. So since as discussed earlier, that the different greenhouse, the lifeline of different greenhouses gases is different. So, for example, some stay for example, like methane tends to stay for approximately 12 years, while CO2 stays for a longer period of time. So, like what GWP frame are we taking, that also affects the their values, GWP values. For example, if we take a time frame of 20 years and then we take a time frame of 100 years, see, you can see in this picture also, like the GWP values of 20 years and 100 years are different for nitrous oxide. For example, these GWP 100 values for methane. For 100-year scale, the GWP value of methane is 28, and for CO2, it's just 1. You can clearly see that it is 28 times it has a global warming impact. For example, GWP 100 of methane is 28, meaning that 1 ton of methane would have 28 times the warming impact as compared to 1 ton of CO2 over a 100-year of period. So in the question, we have asked the GWP value of methane. So it will be 28. Now coming towards the GWP values of the fluorinated gases, CFCs or hydrofluorocarbons, HFCs or hydrochlorofluorocarbons, HCFCs, these are basically they trap substantially more heat than CO2, and thus their GWP values will be very much higher. See, you can see that that is their lifetime of these greenhouse gases, and you see their GWP values, how much harmful these CFCs are. You can clearly observe from these GWP values, because they can be in thousands or tens of thousands. That is why we are more concerned about these CFCs in the atmosphere, because on the one hand they're interfering with our ozone layer, and on the other hand they have such high GWP values, so they are substantially they trap more heat as compared to our normal gases like methane or carbon dioxide. So next up we have dash refers to the long-term shift in the temperature and the weather patterns. So we have our options as acid rain, ozone depletion, then we have climate change, and then greenhouse effects.
Climate change, ma'am.
Yes, it will be climate change. So basically, climate change refers to the long-term shifts in the temperature and also the weather patterns of the Earth. Okay, can anyone tell me the difference between the climate and weather? These two are the terms that are used very frequently in our day-to-day life. So, what's the difference in between climate and weather?
Weather is the day-to-day meteorological changes in the surroundings, ma'am. While climate is the long-term changes of meteorological phenomena like rain and heat, ma'am.
Yeah, true. Good, Harsha. Yeah, it's correct. The weather is basically refers to the short-term changes. Excuse me. Weather refers to the short-term changes in the meteorological conditions. On the other hand, your climate, it refers to the long-term shifts in the temperature and weather patterns. So, climate change basically, when we talk about climate, we talk about a longer duration of time. It may be of a certain decade or a century or like that only. So, see, what is climate change? So, so basically, the climate change, this refers to the long-term shifts in the temperature and weather patterns. These shifts can maybe either maybe natural or such as through variations in the solar cycle or due to the like movement of the earth or the sun. But since the 1800s, human activities have been the main driver of the climate change. We all know that, like how anthropogenic activities, for example, like burning of fuels, then deforestation, and then other activities, how they have affected the climate, and which is primarily due to the emission of your greenhouse gases from burning of fossil fuels, that which include coal, oil, and gases. So these are the major drivers of the climate change, and these greenhouse gases acts as a like a blanket wrapped around the Earth, trapping the outgoing radiation from the Earth's surface and thus raising the global atmospheric temperature. So how like how these greenhouse gases uh, tend to increase the surface of the earth. Basically, what happens is, I've told you like this is a sun, this is our sun, na? Some amount of heat is coming from it. Some gets trapped inside, some gets absorbed, and some gets reflected back. So what these greenhouse gases do tend to do now, they form a blanket around the earth on the surface of the earth, like not the surface, basically somewhere at some higher points. They form a blanket. So what will happen is the heat that was going backwards now, it will get trapped now inside. It can't go back to the space. So this will lead to the increase in the temperature, global atmospheric temperature, and thus we can observe a change in the climatic conditions. So what are the effects or the outcomes of the climate change? How can we say that the climate is changing, or how can we visualize the impacts of these climate change? So, we can see in different things, for example, in the weather patterns, in the oceans, or changes in the ecosystems. For example, the changes in the temperature and precipitation patterns. Like we can see clearly observe that a few days back we have so high amount of rainfalls in this last week, such high amount of rainfall. We have rainfall, we have hail, we have storms. So that is one thing that can be associated with the climate change, because that is not the season of the rainfall. And also the temperature is very much changing very much frequently, like summers are getting very much hotter, winters are getting relatively less colder. So this is the temperature and the precipitation patterns that are being changed due to this climate change. Next up, we have the changes in the ocean temperatures and also the sea level. We can observe that the sea level is rising at a very low, but at a certain rate. So this rise in the sea level is due to the melting of the glaciers and sea ice. This one. Hmm. Ultimately, the water that is being generated due to this melting of the glaciers and sea ice, that is getting into the oceans and seas, and thus the water level in these oceans and seas is rising at a certain amount, at a certain value. Then we have changes in the frequency, intensity, and duration of extreme weather events. These extreme weather events, for example, your hailstorms or like heat waves and something like that. So their frequency is changed and their intensity is also changed due to this change in the climatic conditions. Now, we can also observe the shifts in the ecosystem characteristics, like the length of the growing season is changed, timing of the flower blooms is changed, and also the migration of birds. This is one great example of this climate change, because some birds, due to this climate change, we can observe that some birds which we used to see around in our environment or around our homes in our childhood, we are not able to see them in nowadays, because due to this shift in the climatic patterns now, they have migrated to other places, or they've become started becoming extinct. So this is an effect of this climate change. Now coming towards the next question, we have Dash is an urban center that is warmer than the surrounding or the less populated areas. So we have Heat Island, then we have Sink, then we have reflectivity, and then we have absorption.
Heat
Heat
island.
island.
Yes, Heat Island, correct. So basically, what is Heat Island? It's an like it is caused due to the it is found as an byproduct, or it is formed due to the effect of this climate change, because since the industrial evolution, human activities have released a large amount of CO2s and other greenhouse gases into the atmosphere. We all know that, and this has led to the change in the global temperature. Basically, the global temperature of the earth has risen due to these activities, and thus the earth's climate has changed considerably. So, the natural processes such as the change in the sun's energy and volcanic eruptions also this also affect the Earth's climate. Okay, so let's quickly get into the effect, like the activities that have contributed substantially to the climate change. For through first one is greenhouse gas emissions, and next is your reflectivity or absorption of the sun's energy. So the greenhouse gas emissions, basically CO2, it gets released due to burning of fossil fuels, methane, nitrous oxides. They also, these are all the gases, greenhouse gases, that are being released from our day-to-day activities. Then, the activities that affect the reflectivity or absorption of the sun's energy. Like, what are the activities that tend to affect the reflection or the absorption of sun's energy? First one is agriculture or road construction. Basically, these may change the what's the term? Okay. These activities change the reflectivity of the Earth's surface, and it may lead to your local warming or cooling, because construction of a road, it tends to absorb construction of a road of a certain at a certain place, and the removal of that greenery from that area, it tends to absorb more heat, and thus the temperature will rise as compared to an area where vegetation is there. So this local warming or cooling, this is effect is observed in heat islands. Basically, these are the urban centers which are warmer than the surrounding or the less populated areas. So one reason is that these areas are why these areas are warmer is that buildings, pavement, and roofs, these tend to reflect less sunlight and absorb more sunlight than the natural surfaces. So this can be observed in cities such as Mumbai, Delhi, where heat wave warnings are being issued in the summer seasons, because they have a lot of buildings and pavements, construction is there, and lesser amount of greenery or the green areas there, which tends to reflect the heat. And these buildings and pavements, they reflect less sunlight and absorb more sunlight, and thus the temperature rises. What are the natural processes which causes these climate change? First one is the changes in the Earth's orbit and rotation. So the changes in the Earth's orbit and its axis of rotation have a big impact on the climate in the past. We all know that the Earth's orbit can be changed in terms of its eccentricity, in terms of its tilt. This angle is getting changed by certain degrees. Then the amount, for example, the amount of summer sunshine on the northern hemisphere, which is affected by the changes in the planet's orbit, appears to be affecting the past cycles of ice ages, because the amount of summer sunshine is increasing, and due to this, the ice is getting melted, and the cycles of the ice age is getting reduced. The Earth has experienced longer periods of cold temperatures, ice age, as well as shorter interglacial periods between the ice ages of relatively warmer temperatures due to this changes in the Earth's orbit and rotation. Now, next we have your volcanic activities that say volcanoes have played a noticeable role in the climate as the volcanic eruptions release a large quantities of carbon dioxide in the atmosphere. So, some explosive volcanic eruptions can throw particulate matter in the atmosphere, and they tend to act as a blanket, like these particulate matters. These tend to act as a blanket in the upper atmosphere where they can reflect enough sunlight. They tend to, these act as a blanket and they reflect the sunlight. Like whatever sunlight that is coming, they reflect them and not letting them to come towards the lower atmosphere. So they have a cooling effect on the planet. On the contrary, like the changes in the naturally occurring carbon dioxide concentrations over the last several hundred years, carbon dioxide levels varied with along with the glacial cycles. During the warm interglacial periods, these CO2 levels were higher, and during the cool glacial periods, these levels were lower because this CO2 is like responsible for trapping of heat. So the heating or cooling of the Earth's surface and oceans can cause the changes in the natural sources and sinks of these gases. And thus the change in greenhouse gas concentrations in the atmosphere gets changed due to this changes in the CO2 concentrations. So next is which of the following is not a type of acid deposition? Wet deposition, dry deposition, snowfall, or volatilization?
Snowfall, ma'am.
Snowfall. Okay. See. Okay, so we have first one is forms of we have forms of acid deposition is first one is wet deposition. So wet deposition is most commonly known as acid rain. We all have read about this. So the sulfuric and nitric acids formed in the atmosphere when they turn to mix with the water vapors and they fall to the ground and in the form of rain, snow, fog, or hail. So this is your wet deposition. Then we have your dry deposition. So the acidic particles and gases can also deposit from the atmosphere in the absence of moisture as the dry deposition. These acidic particles can also deposit in the atmosphere. So these can be deposited onto the surface of water bodies or vegetations. You can observe that at certain places the leaves of the plants tend to get affected. Like we can observe the drying or the of the leaves or some kind of like discoloration in the leaves, that is due to this dry deposition of the acids onto the vegetation. So this is your form of dry deposition. So snowfall is also a certain type of wet deposition. See, snowfall, rainfall, fog, or hail, this all comes under this wet deposition. So this will be your volatilization. You can say snow, rain, fog, or hail. All this comes under this wet deposition. Now the next question. The normal rain is slightly acidic, that is, its pH is approximately 5.6. It's because carbon dioxide dissolves it to it and forms weak dash acid. So, which acid is formed due to this carbon dioxide, and why this
कौन है तेरे
Ma'am,
को?
it's
first is nitric which one?
carbonic.
Carbonic acid. True, true. It's carbonic acid. Okay, so how do we measure the acid rain? How do we find out the pH of the acid rain? Let's quickly have a look into it. So basically, these terms, acidity and alkalinity, these are measured using a pH scale, and for which 7 is neutral, less than 7 is acidic, and more than 7 is basic or alkaline. So the lower the pH of a substance, 1, 2, 3, this is more acidic. Like the less the level of pH, the more acidic the substance is. And the higher the pH of a substance, 12, 13, 14, so the higher the pH of a substance, the greater or the more alkaline or basic that substance is. This is how we measure the pH of any substance. Now, we know that the normal rain has a pH of about 5.6. So it is slightly acidic because the CO2 that is present in the atmosphere, we know that the CO2 is present in a large amount in the atmosphere. So what it does, it tends to react with the water vapor, and forms a weak carbonic acid, that is H2CO3. So this is why see, normal water or the distilled water has a pH of about 7. It is normal, neutral. But due to the formation of this carbonic acid, the pH shifts towards this is 7. This is your cycle. Here we have 14. Here we have 1. This is your acidic range, and this is your basic range. So due to this carbonic acid, what happens is this pH, it shifts somewhere towards the left, and thus it comes on the acidic range. This pH is about 5.6, and that's why the rain is termed as acidic. The normal rain has a pH of about 5.6, and that is why it is slightly acidic. So basically, this is the pH of normal rain, but the acid rain that we discussed earlier, the pH of acid rain is usually between 4.2 and 4.4, which is a considerable amount of acidity that can be expect. These are some of the examples of the pH values. For example, battery acid has a pH of almost 0. Then we have lemon juice, its pH is almost 2. Soda has pH of 2.5. Then acid rain has pH of 4.3. Normal clear rain, we have pH of 5.6. Distilled water has pH of 7. Then blood is slightly basic. Like its pH is approximately 7.4. And the seawater, we all know that it is alkaline in nature, so its pH is almost 8.1. Then baking soda, that is also alkaline in nature. Its pH is 9. Then we have ammonia, its pH is 11. Bleach, that is chlorine bleach, its pH is 12.6. And then the liquid drain cleaner, its pH is 14. It's very basic in nature. Now, how can we measure the acid rain? How can we measure the pH of the acid rain? So first one is one easy way. We all have done this in our laboratories to measure the pH, that we can use a strip of litmus paper. So we have litmus paper. We have two colors of the litmus paper, and like uh, it depends on how the color changes, whether the substance is acidic or basic. That can be observed with the change in the color of the paper. So if the paper turns red, then it shows that the substance is acidic, and if the paper turns blue, then it shows that the substance is basic in nature. So red is for acidic and blue is for basic. Then how scientifically the measurement is done. So the policymakers or the research scientists, the ecologists, and also the modelers, they rely on the national atmospheric deposition programs, uh, National Trends Network (NTN) for the measurements of the wet deposition. So they collect the acid rain at more than 250 monitoring sites throughout the US, Canada, Alaska, Hawaii, and the US Virgin Islands. They collect the samples of the acid rain, and then they test those samples and give out the values of values of acidity, or the measurement of the pH is done. Unlike the wet deposition, the dry deposition is difficult and expensive to measure. So, the dry deposition estimates for nitrogen and sulfur pollutants are provided by the Clean Air Status and Trends Network by the US EPA, and air concentrations are measured by CASNET at more than 90 locations. So, this is how the wet and dry deposition is done, and this is how the acidity of the rain is found. So that's all for the questions for today's class. Now, if you have any doubts, we can discuss them, or if you are having any doubts for the current week's assignment, we can take them as well.
Good evening, ma'am. I have a doubt, ma'am.
Yes, Harsha.
Ma'am, radiative forcing is measured as watts per square meter, ma'am. So I can't understand how it got that unit, ma'am.
Okay, let's get into that topic, radiative forcing. This one, no?
Ma'am,
Basically, see, this radiative forcing, it is the amount of heat that is represented in terms of watts, and per square meter. This is square meter is the area that we are considering for our calculation purposes, because see, we are finding out this trapping of heat at for some specific area, like how much heat is getting trapped by a certain amount of gas for some area. So that is why that this per square meter is there, because when we club all these values now, then we get the average, or the overall impact, that whether it is warming or it is cooling, like whether it is positive or the negative forcing. So that is why it is watts per square meter.
so heat is measured in watts, ma'am.
Yeah, heat, or you can say, like, it's the unit of power, basically watts, no?
Thank you, ma'am.
Basically, it's the energy, like in the form of heat that we are calculating. So it is energy that is getting trapped.
Yes, ma'am.
Any other question?
No, ma'am. So the heat energy is having the same unit as power, ma'am.
Yeah, energy can be termed in can be explained in terms of what?
Thank you, ma'am.
So how are your classes going on? Like, I guess you must have read these air pollution control devices in last week only. Were you able to understand those topics?
The data part is difficult to remember, ma'am, but the concepts are with the explanation. It is easy to understand.
Okay. So you'll be expecting like a few numericals from that part also. So just it's good if you practice like a bit uh, conceptual questions from that. I'll try to take that in my next lecture also. I'll take apart from these assignment questions, I'll try to take some numerical questions as well from those because that is one important topic from your course. Any other topic that you guys are having any doubts or any confusion or you want to understand that we can take in our next lecture also?
Like you said, the instruments is a little difficult to understand.
Okay, so I'll do one thing like before starting our assignment questions in the next lecture now, I'll quickly take all the instruments and explain them like the basic concepts behind them and how to solve the numericals. I'll try to explain them in the class only.
Thank you, ma'am. The radiative forcing it's given energy imbalance, ma'am. So what is coming inside, some is observed, and then only few is left out, ma'am. So uh, why does the energy imbalance take place, ma'am?
See, this energy imbalance is due to different factors. See, we are receiving energy from the sun, but like some amount of it gets trapped or the absorbed by the surface of the earth due to different factors. For example, the buildings, the pavement, they tend to absorb some amount of energy. Some other activities like the albedo of the earth that like affects the amount of energy that is getting trapped. So when this incoming and outgoing energy that gets imbalanced due to all these factors, then there is a certain change in the overall temperature of the earth, because if the incoming energy is more, that the energy that is getting absorbed is more, is more, then we'll have a warming effect, and this is termed as your positive forcing. And when this the reflection is more and less is getting absorbed, then we have an overall cooling effect or the negative radiative forcing. So
Thank you, ma'am.
this imbalance is due to different natural or the anthropogenic causes. Mainly, it is due to our human activities. The emission of aerosols, the emission of greenhouse gases, and the changes in the albedo of the earth due to the land use patterns, the changes in the cloud patterns due to the deposition of these aerosols. All this have an effect on the radiative forcing.
Some doubt, ma'am. So why do we say that urban centers are heat island, ma'am? So it is not like island. If you said an example as Mumbai, ma'am. So Mumbai is not an island. So why are we saying as heat
See,
island?
island is basically, see, island is referred to as a, here it is referred as a term. We can observe, see, at an island, it is a landmass which is surrounded by water. So it is like the properties or the weather or the climatic condition it is having is very much different from the surrounding areas. So same way we are referring in terms of heat or the climatic conditions कि वहां पर जो temperatures होंगे उस particular area पर जो भी amount of heat present होगा that is more as compared to the nearby areas. That is why we are referring them as heat islands.
Yes, ma'am. Thank you, ma'am.
Yes, Rompa?
Hello,
Yes.
मैं आई मैम ये क्या ओनली अर्बन एरियाज में ही बनता है या फिर कोई ऐसे कॉजेज भी हो सकते हैं कि रूरल एरिया में ये डेवलप हो जाए?
Definitely, definitely. It can be formed in the rural areas as well because you can observe that in some rural areas जहाँ पर climatic conditions इतनी worse हो जाती है that they have drought conditions or due to lesser amount of vegetation. See, rural areas में क्या होता है? We have a large amount of burning of fire is there. Like combustion activities are way more than in urban areas. सो उनकी वजह से भी कई बारी क्या होता है दैट द टेम्परेचर टेंड्स टू इंक्रीज सो डेफिनेटली इफ सच क्लाइमेटिक कंडीशंस आर देयर कि वहां पर भी टेम्परेचर्स बहुत ज्यादा हाई हो जाए तो इट कैन बी ऑब्जर्व्ड इन रूरल एरियाज एज वेल इट्स नथिंग टू डू विद ओनली द अर्बन एरियाज रूरल एरियाज में भी अगर टेम्परेचर्स हाई हो रहे हैं ड्यू टू सर्टेन एक्टिविटीज और सम क्लाइमेटिक कंडीशंस और सम नेचुरल फैक्टर्स then we can observe the heat islands there as well. But
So
certainly due to these, uh, yes, Rumpa. But s- certainly, see, the anthropogenic activities in the urban areas are way more harmful as compared to the rural areas. Because, see, the first factor is that there the population is very less. So, the emission levels if we consider them as a whole for this specific area, the emissions are quite less as compared to the urban areas, because there the topography is totally different. Like we have tall buildings, we have pavements, we have pakka roads. So they, all of them also tend to accumulate some amount of heat. So that is why this term is in general used for urban areas, but it can be for rural areas as well, but in very special cases, not in general cases. So, any other doubts you guys have?
Ma'am.
Okay. What about you, Rumpa? Do you have any doubts?
No, ma'am.
Okay, so I guess we should end this class today, and we'll take those air pollution control devices. Our next class will be on usual time, that is on Tuesday from 6 to 8 p.m. It was just for this week only that I couldn't take the class on time. So see you on Tuesday from 6 to 8 p.m. And in that class, I'll be discussing the air pollution control devices. I'll be explaining the concepts of those devices, and then we'll take the numericals or the assignment questions. Okay, so that's all for today. Thank you.
Thank you, ma'am.
Ma'am.
Okay, see you. Take care.
Bye, ma'am.